Welcome to the 38th ISBS conference, which is offered online for the first time. My name is Boris Bacic from Auckland University of Technology in New Zealand. Today, I will discuss the topic of backswing length and swing path tendencies from amateur golfers. We will explore three questions. Can the length of the backswing contribute to a tendency to produce a non-ideal impact with the ball? And if it can, how does backswing length affect swing path at impact and thus ball flight trajectories? And finally, should the short-end backswing be of everyone's interest, whether they are golf enthusiasts, novices, coaches, or competitors, regardless of their handicap level? As we know, there are three variations of backswing length. First, there is the regular swing, which has traditionally been viewed as the ideal backswing in which the club is parallel to the target line at the top of the backswing. The second is the shorthand backswing, which is the topic of this presentation. Here is a link to Golf Channel, where a golf pro explains and demonstrates three different shorthand backswings and how everyone can learn them and customize their own game. So what we can see for players executing shorter backswing in various videos and golf tournaments is faster rotation and acceleration with more aggression through the ball. Finally, there is the longer backswing shown below. This is preferred by those who would like to extend their X factor, the increased rotation and separation angle between hips and shoulders, which should in theory increase distance. However, we should also consult some recent publications linking X factor and back pain and golf injuries. In recent years, we have seen an increasing variety of personalized backswing lengths becoming popular amongst competitors. So this raises the question, what is the impact of different backswing length on ball trajectory? What constitutes an ideal backswing, one that would work for you? And here below we can see long backswing executed on a shorthand size driving range of AUT University, using in our experimental settings, and also John Daly's artistic impression of his long backswing together with Google image search. So next slide, let's see what happens at impact with a ball. At 160 km/h drive, it is hard to strike the ball with millimeter accuracy in the center of the club sweet spot. And if the club head misses the target line at impact by 2 degrees, we create a non-ideal impact with the ball. So also known as swing path, which we see on the figure as outside-in error, which is most common and marked in red, inside-out error in blue, and parallel, which is ideal, are intended parallel to intended line around the impact. Combining a non-ideal swing path, club face angle at impact, and also missing the sweet spot generating gear effect and ball spin variations shown here would altogether result in 9 ball trajectories. So on the shortened size driving range that we used in our experiment, we can only see initial ball takeoff, but not the actual ball flight, which would prevent golfers from compensating their swing, which bring us to the experimental setup and the data collection. So with AUT ethics approval being obtained prior to the experimental data collection, the intention was to collect a data set from a sample of amateur golfers, where the majority were novices and few already played golf, and only one declared a single-digit handicap. Of the novices, all 10 went through standardized golf coaching lessons aligned with the NZPGA program, while intermediate level golfers received more personalized feedback. So rather than seeing produced ball trajectory, all participants received feedback focused on their swing performance, which was augmented by video evidence from front and sagittal camera views, and a 3D reporting system from smart club sensor technology used in our data collection. Regarding golf club sensor design, today there are many inertial sensors for golf, and driving ranges are also getting equipped with ball flight tracking technology, to which players can connect with a mobile app in order to receive augmented feedback and swing statistics. The smart swing sensor used in our experiment was one of the first on the market, which was embedded in the handle of a driver club. The sensor captured club movement at 1000 Hz. The smart swing software provides also replay and measurements associated with each swing, which is stored in proprietary database with no option to export collected data into a spreadsheet format. Which brings us to the next slide. To avoid manual data export, I developed a data export utility whose text mining processing framework I published in 2016. Nowadays, there are free web services and other software available for similar tasks. However, sports scientists seeking to undertake their own data collection should bear in mind end-user licensing agreements, and that wearable technologies often use cloud computing and do not allow direct data export nowadays, which may raise ethical concerns around privacy. So there is also a video demo on that article in the journal. It's experimental results. As we see here, our data analysis shows that golfers with longer backswing had a greater tendency to produce outside-in errors, over 93%. For participants executing shorter backswings, the distribution of ball impacts changed, with more inside-out errors leading to draw, push, or hook ball trajectories, but also an increase of desired parallel, i.e. straight shots, by almost 7%. The dominance of outside-in ball errors is significantly reduced by 17.76%. Increased standard deviation for shorter backswing, shorter next to the bar graph, provides evidence of coaching practice focused on developing the backswing naturally. So, implications, and regarding a contribution to sports science, as mentioned earlier, to export data from sport technology, we can develop our own solution in Python, MATLAB, or use free optical character recognition web services such as Give Me Text website link and other free software for image segmentation and manipulation. For golf enthusiasts, when to learn short and swing, my suggestions are: for approach shot, you should learn it as advanced beginner or as you transition from driving range to a golf course. As for standard shot alternative, I would advise this at advanced intermediate level after you have developed your own game, your standard swing, and learn how to control fade and draw ball trajectories. Then you should consider it a shot alternative. So in conclusion, from collected swing data set, we investigated the role of backswing as how does backswing length affect swing path at impact and thus ball flight trajectories, and found out that those with a tendency towards long backswing on a reduced size driving range are more likely to hit outside-in errors by greater than 70%, which also means more slices. Is the length of the backswing affecting our tendency to produce more errors at impact? The answer is yes. Should the shorter backswing be of everyone's interest, whether they are golf enthusiasts, novices, coaches, competitors? The answer is yes, definitely. Why would we want to learn additional backswing style? Well, for safety, ball placement being a parameter, and consistency, whatever can improve our game. Whether you wish to extend your X factor, or you feel acute or chronic back pain, or perhaps loss of mobility of our range of movement, which happens in aging. As a game strategy, you can consider club up and shorten backswing when you start a competition experiencing a bad day. Or you can also consider to have fun playing or practicing with half set of clubs and develop confidence. So the future work is to extend this investigation to 3 areas, so to include more advanced beginners and low handicap players on a full-size driving range, and to provide more evidence on can shorter backswing help to improve consistency. Thank you for watching this presentation. I hope to discuss this work and exchange some further thoughts with you in person, hopefully in the near future.